Welcome. Let's get started on the Chapter 6 study guide with the first one. Find the sum of the interior angles of a hexagon. So our interior sum is n minus 2 times 180, and a hexagon is 6 sides. So our n value is going to be 6. So that's just going to be 6 minus 2 times 180. And then we just make sure we have our calculator out and ready. So it's going to be 4 times 180. Which is 720. Next, find the sum of the exterior angles of a heptagon. Well, the sum of the exterior angles, no matter what, is 360. It doesn't matter the side length. So we're just going to quickly and easily just write in that we have, 360. Find each interior angle of an octagon. So we can use the octagon, each interior angle formula right here, n minus 2 times 180 divided by n. And octagon is 8-sided, so this is just going to be 8 minus 2 times 180 divided by 8. So we'll evaluate the top first. That's going to be 6 times 180, which is 1080. So that's the sum, but then each one, and it's a regular, which means all angles and sides are congruent. Divide by 8, we get 135. Find each exterior angle of the nonagon. Each exterior angle is going to be 360 divided by n. And so to get that, we are going to just simply do 360 divided by n, which is 9. And that is going to give us 40. Find the number of sides of a regular polygon if each interior is 108. So we had the each interior formula, which was right here, and we just set it equal to 108. Okay, and so we can do it this way. Another thing we can do is if this was the shape, right, 108, the exterior angle would be 72 degrees, and we know the exterior angle and the interior angle should add to 180. And so the reason why I show this is because it's actually a little easier to do this one, okay? If I know the exterior angle. So I'm going to do number 6 real quick. It says find the number of sides if each exterior angle measures 36. Well, the sum of the exterior is 360, so we just have to divide it by 36. So we get 10. So the answer to this is 10. So all you have to do, if you know that each exterior, just divide it into 360. So here we just go 360 divided by 72, and I think that's 5. And you get 5, which is the correct answer. So this is a lot easier if you are asked to find each interior, find the sides given the each interior. I would find the exterior. It's much faster to do. But you can use this formula. I'll show you how to do it. Multiply the n out. So this becomes n minus 2 times 180 equals 108n. And then distribute that, so you get 180n minus 360 equals 108n. And then I can subtract this 108 over here, which would give me 72n minus 360 equals 0. Add the 360 over, and then divide, and that gives you 5. So either way, you're going to get the right answer. Again, I would probably be more apt to get to do it this way. It's a little bit faster. Okay. Find the number of sides if the sum of the interior. Well, we know the sum of the interior is just this equation, so we just set it equal to the sum. Okay. So these bottom ones are doing kind of like the reverse. We're finding n. The other ones we're plugging in n. So here I would divide by 180. And so n minus 2 is going to equal 2,520 divided by 180, which is going to give us 14. And then add the 2, which will give us 16. Whenever you're asked to find the number of sides, you better get a whole number. Okay, you cannot get a non-whole number. So make sure you get a whole number for us. Okay. All right, moving on. Number 8, it says find the figure below. So we have all the sides here or all the angles, so we could add them up and set it equal to the sum of the angles. This is a 5-sided figure, so we're going to do 5 minus 2 times 180, so we know the sum is 540. So we just basically have to add all these up, so 540 equals, and then we add all of them. So 5x plus 2 plus 10x minus 3 plus 8x minus 19 plus 13x minus 31 plus 7x minus 11. And we just got to be nice and careful we don't miss anything. So 5, 10, 8, 13, 7. So I'm just going to add those numbers up. 5, 10, 8, 13, and 7. So that should give me 43x. And then we're going to go 2 minus 3 minus 19 minus 31 minus 11. And that should get negative 62. Okay. I'm going to add the 62 over, which should give me, I think that's 602. Let me double check. Don't want to make a mistake. Yep. And then divide by 43. X should equal 14. And that's all we're finding. In our picture to the right, we're using a square. So we have to remember a square has all the information of a parallelogram, rectangle, rhombus. And I do like to mention that the square, no matter what, the angles are all 90, and when the diagonal comes in, it splits it at 45s every time, no matter what the shape is. Okay, that's the rectangle is the only one, or sorry, the square is the only one that does that. So ABD is this guy right here, and so trying to find that guy, well, it's just going to be 45 degrees. We actually just saw it in the little picture there. No matter what, it's going to be 45 degrees. So we should feel pretty confident that that's what we're going to have. And we can now move on. BEC. So BEC, so E's in the middle, so we're talking about this guy right here. So BEC is this angle here. Well, again, in a rhombus, the diagonals are perpendicular, which is also true for a square, so we're just going to set this equal to 90. So we get 3x, subtract that to 81. 81 divided by 3, I think it's just 27, that's right. And we get 27. Okay? And then the perimeter of ABCD is 56, and we have 2x plus 4 is CD. So all the sides are congruent, just like a rhombus. So what we want to do is we want to take this number, divide it by 4, because there are 4 sides. So that means each side length is 14, which is the measure of CD. So we're going to subtract the 4, we get 10 equals 2x, so x should equal 5. Okay. Moving right along, we get our next problem, which is use the picture to the right for the parallelogram. So we're only using parallelogram rules. So we know that opposite sides are parallel congruent, opposite angles are congruent, consecutive angles add to 180, and diagonals bisect each other. Okay, so JN right here is 11, and JL, the whole thing, is 4x minus 2. Well, if this is 11, that means NL is also 11, so the whole thing, JL, is 22. So I could do 22 is equal to 4x minus 2. So that means 24 equals 4x, and I believe that goes in 6 times, and x will equal 6. Okay? And then we have MN. MN is right here, so that's 2x plus 3. And then NK is 5x minus 9. Again, diagonals bisect, so those two should be congruent. So we subtract there, we get 3x, add the 9 at the same time. X is going to give us 4. And then it says find MK, which is the whole thing. So if I plug 4 back in, we're going to get 8 plus 3, which is 11. Okay, so MN is 11. Well, if this is 11, that's 11. The whole thing is going to be 22. JM. JM is the side length here, 4x minus 7, and then KL is 6x minus 11. We know opposite sides are congruent, so we're just going to set them equal to each other. Subtract that over, which gives us 2x. Add 11 over to this side, that's going to give me 4. That means x equals 2. Okay, our picture's getting a little convoluted, so we might need to redraw it real quick for these next two problems. Okay, so JML is the entire angle of 84, and then we're trying to find this angle. Well, remember, the two consecutive angles add to 180, and so if JML is 180, then MJK should be what is that? 96 degrees. Because 96 plus 84 should make 180 degrees. And let's see here, one more drawing. Okay, so I'm just using the letters up here to help me find it. JLM is 29, that goes down there. JNM is 80 right there, and we're finding JKN, which is right here. Okay? Well, if this is 29, we know that these lines are parallel, so that's also 29 by alternate interior angles. And then we can go ahead and calculate this guy is 100 because that's a linear pair. And now I have a triangle right here, and all three angles of a triangle add to 180, so I just have to add those up and set it equal to 180 and basically solve. So it's going to be actually 180 minus 129, which gives me 51. That's my final answer. Okay, moving on. So it's a square, a parallelogram. We have now a rectangle. And so the rectangle, we have to remember, has 4 right angles, and the diagonals are congruent, plus all the attributes of a parallelogram. So first things first, they give me PR and QS, which are diagonals. We know they're congruent, so we set them equal to each other. Okay, subtract that, you get 6x. Add 4, you get 12. X equals 2. Find TQ. Now TQ is only half of SQ. Okay, because remember, they get bisected as well. So when we plug it back in, we get 3 times 2 plus 8. That's going to be 6 plus 8, which is going to give me 14. So if the whole thing is 14, then we're only dealing with half of it, which is 7. All right, and then number 18, if QPT, so QPT, so this angle right here is 36, find TQR, so this angle here, okay? Well, if this is 36, then we're going to get, let's see, did I put that in the right place? Yep, and we're finding TQR. Yep. Okay, so 36 right here. So remember, we said before that we have all these are congruent, which makes isosceles. So if this is 36, then this is 36 over here as well, because this is an isosceles triangle right here. This guy is isosceles because we have PT is congruent to TQ. And so because of that, that's why we get to put 36 here as well. Now, X and 36 form 90 degrees. So we basically just take 36 plus X, and we can set it equal to 90. They're complementary. And so we can go ahead and solve those pretty easily by doing a little subtraction. So 90 minus 36 gives us 54. Number 19 is a Pythagorean theorem problem. I'm just going to do it quickly. But basically you're looking at these lines right here, whoop, went dark on you. This is a 90 degree because of this is basically this part of the triangle. And it says QR we don't know, SR is 7. It says PR is 14. That means SQ is also 14 because diagonals are congruent. So you're going to get 14 squared equals 7 squared plus x squared. This won't be on the test, but here it is. And we get that, subtract it. So 196 minus 49 is 147. So we end up with 147 equals x squared. So we take the square root of it. If you take the square root of it, you're going to get the value of 7 rad 3, or about 12.1, which is what they want you to get because it's rounded to the nearest tenth. Okay? All right. Let's go to this one right here. We are now into the rhombus world. And rhombuses have 4 congruent sides, diagonals form 90, and diagonals bisect each other. Bisect each angle. So BAC right here is 3x minus 1. And then ABC is 80, so this whole thing is 80. Find x. Okay, well, if the whole thing is 80, that means this is bisected, so that's 40 and 40. We know this is 90. So this angle right here has to be 50. Because 40 plus 50 plus 90. So that's why 3x minus 1 is going to, 3x minus 1 is going to equal 50 because the 80 gets divided in half. This is 90 because all of them are 90 there, and that's what we're going to do. And so we're going to add the 1 over, so that's 3x equals 51, and then 3 should fit into that 17 times. Find the perimeter of ABCD if AE equals 5 and DE equals 12. So we have 5 and 12. So this is, again, a Pythagorean theorem. You won't see this on the test, but you have 5, 12, and x. If we can get the side length, we can multiply it by 4 to get the perimeter. This is actually a Pythagorean triple, so actually I already know it's 13. Because 12 squared plus 5 squared equals 13 squared, and then 13 times 4 is going to give us the perimeter, and that's going to be the value of 52. Okay. All right, last 3, and we're talking about trapezoids, but more specifically the isosceles trapezoid, which has 2 congruent legs right here and here, has 2 parallel bases right here and here, 2 sets of congruent bases, so these are congruent, these are congruent, and the diagonals are congruent. And then we also have the midsegment, trapezoid midsegment theorem as well, which is the top base and the bottom base added together divided by 2 equals the midsegment. So first question, we have A, B, and CD, and we're trying to find EF, so this is just our basic midsegment. Add the bases, divide by 2. So 9 plus 25 divided by 2 is 17. So we have the same thing, but this time we have all the information, so we just are doing more of algebra. So AB again plus CD again divided by 2 equals EF. And so what we're going to do here is we're going to divide. Okay, so on these ones I like to multiply the 2 out. And then whatever you do to one side, you have to do the other. So we end up with 26 over here. And then I can just combine like terms. So it's 2x and 6x is 8x. And 3 and negative 9 is negative 6. So add the 6 over, and we're going to get 32. And divide by 8 should be 4, I think. And x equals 4. The last one, 118 is here. So what's C? Well, B would be 118 as well, and then remember, these 2 angles add to 180, okay? So consecutive angles add to 180. So 118 plus angle C should equal 180. That makes it 62. All right, everybody, good luck.